Can you find the two half reactions on your reduction potential table?
Mr. Moore,
Mm-hmm.
for when you write the equations, do you have to include if it's like aqueous
Nah, you don't need to do that.
notation?
Yeah, give your best shot at the line notation, then we'll talk about it. I'm going to go ahead and turn it over to the next slide that has the solution on it. If you're not done yet and you don't want to look, then don't look yet. Each half reaction has a metal in it, so that metal will be the electrodes that you use for each half. They're labeled anode and cathode. Hopefully you got that value for the cell potential. Yeah.
So you don't write a coefficient?
In the line notation?
Yeah.
Right, the line notation never has to be balanced. You just have to say what the reactants and what the products are. Yep, Matthew?
How do we know what is in the solution? Like with magnesium, it's the starting, and with the aluminum, it's what it.
Yeah, in both drawings, on the left and on the right, you have to write down what the reactants and the products are. You have to include both in your drawing. Yep. The magnesium is a reactant. The magnesium ion is a product, so they both have to be over there. And over on the cathode side, the aluminum ion is the reactant. The aluminum bar is the product. So that's got to be, both those have to be in there too. Now with the line notation, again, it doesn't have to be balanced. The single vertical line separates physical states from each other. So magnesium is a metal, it's a solid. Magnesium ion is an aqueous thing. So they have two different physical states. So that's what is separated by the vertical line. And then the double line separates the anode from the cathode. Anode always has to come first. It always does when you do the line notation. And the cathode's over here. Remember, the first thing written is the electrode for the anode. The last thing written is the electrode for the cathode. The electrodes, these bars right here, always are on the ends. The first thing and the last thing written in the line notation are always the electrodes. Okay? So the aluminum ion is changing to aluminum metal, and that's our line notation. Any other questions that you have? Go ahead.
Are like the ions with like charges always in the solution? Like
Yes. Yes, they'll always be.
not on the bottom?
Right. Yep. Because the bar has to be a neutral metal. Yep. Mm-hmm.
What about like on the image yesterday, it was showing like a little bit of like decay on the left, and then some of the right gains. Is that because the Mg is turning to Mg2?
Yes.
And then the Al.
Right. As the electrons flow out of the magnesium, that's going to cause the magnesium bar to become magnesium ions, and so they don't stay on the bar anymore. So yeah, this thing is going to shrivel and get consumed.
What about the aluminum?
Now the aluminum, yeah, it's going to get bigger. If we weighed the beginning, the mass of these at the beginning, at the end the magnesium would be lower in mass, the aluminum would be higher in mass. Yep. Because these aluminum ions are going to gain the electrons coming in and stick onto the bar of aluminum. Yep. Nabil?
So that crystal change, when you draw this out, just so it doesn't get smaller.
Nah, you don't have to. No. Yes.
So the you know how you have to change for like the equation, how you multiply the aluminum by 2 to balance it out.
Yeah.
So then you don't affect that. That's an effect the voltage. You don't multiply the voltage.
Right. That's right. That doesn't affect the voltage. Yeah. Asa?
What was the balanced equation?
Now the balanced equation from the previous slide, this was unbalanced. The aluminum is going to take in 3 electrons, the magnesium gives off 2 electrons. So those numbers of electrons have to equal each other. For the magnesium to give, losing 2 and gaining 3, the common number there would be 6. So you'd need the magnesium to have 6 electrons, so just multiply the magnesiums by 3 to get 6 electrons, multiply the ALs by 2 to get 6 electrons. That would be the balanced equation. Yeah. It never did ask you for what the balanced equation was in these, so you didn't really need it, but if you wanted to know how to do it, yeah. Anything else about this one? If not, we'll go on to the next one. The next one, I actually have the chemicals, so I'll show you what a cell looks like with it. So let's go ahead and see if we can do, yeah, this is the one that I have brought the reactants for. Iron and permanganate. Now this one's going to be different because one of your half reactions will not contain a metal.
Is that minus?
The MnO4 minus. Yep. turn the page and take a look at what the solution is?
Solution. Solutions.
That's true. Don't do that on me. Here's our sketch. Now, part of our sketch is this hydrogen ion. You do need the hydrogen ion in the cathode. I don't know if you picked that up yet, but yeah, that half reaction will not occur without hydrogen ion. In fact, that reminds me. I was going to show you this reaction, but I didn't acidify my permanganate.
Did they put hydrogen in?
Yeah, the permanganate, when it reduces, it does have to have acid in there, or else the reduction won't tend to
How
occur.
would you know it's plutonium?
It's just like.
Oh, not plutonium, it's platinum.
Oh, platinum, that's what I was saying.
When your reactants and products are both ions, then you'd use platinum. We have the reaction, the half reaction for the reduction is a permanganate ion changing into Mn+2. So that's an ion and that's an ion. If neither one is a metal, then you got to use platinum. Now that's not true for the oxidation. The iron changing to iron +2, we have a metal in that half reaction, so you use a bar of iron. Hello? Hi. Yes. Yes, I sure will. Thanks, Pam. Yep, you're welcome. Bye. That was the principal secretary, Ms. Brubaker. She has something for you, a reimbursement.
Oh, yeah, right now?
No, after school. I mean, you can go now if you want to, if you don't trust her.
Did you say thanks, fam?
Pam. It's Pam. You thought I said fam? That's so good. Okay.
So that's always, but how come, but don't we use graphite, so?
Oh.
No, it's platinum.
No, but like here, but like in our labs, don't we use?
No, they look like graphite, but they're really platinum.
Okay.
Oh, what?
No, he's joking.
No. This is my platinum right here.
Yes.
It is?
Yes. Right? We're all okay?
Yeah.
All right.
So that's platinum.
A platinum.
And the,
Yes.
the bird is drinking water, right?
Forget the bird, Amber.
So Mr. Moore, if we were like in our lab, would we write graphite or would we write platinum?
I'm telling you this is platinum, so you write platinum.